I call this the double reveal principle. Now, for this wonderful effect, we need a shuffled deck of cards, okay, which is great. You can start with a randomized deck of cards. Now, once the spectator is convinced that the cards are beyond the knowledge of anyone, have them just set the cards down on the table. Now, at this point, they're free to cut the cards wherever they would like. So perhaps they'll cut it like right there. And now they can choose either portion as their, quote, half of the deck. So maybe they want those, and then that gives me these as the performer. That's just fine. Now, what we need to do, each of us, is we need to go through our individual packets here and choose a card at random, or if you happen to see your favorite card, or a card that just speaks to you, okay? Now, because you're not here and I have to perform, both sides, the performer and the spectator side, you're going to see what card I choose, and I'm going to have to choose yours for you, okay? But in practice, we would not see each other's cards, okay? So just be aware of that. So I'm going through the packet like this, trying to find a card that I would like to set down as a special card. Well, I think I'll just go with this one. This one's, okay, you wouldn't say anything to the spectator, but you just quietly put it down. Okay, that's my card. And then you as the spectator would go through and find a card that, quote, speaks to you, or kind of a nice card to work with. Kind of a classic card would be this one. And then whatever card you choose, you don't show it to me, but you just set it on top of the one I chose, okay? And we could switch the order of those. It doesn't matter which one's on top, okay? So here we are. So we started with a shuffled deck of cards, and then I had the spectator cut the cards into two portions. They freely chose which one to work with, and I got the remaining one. And then each of us individually went into our little packet and chose a card to set down right here. Okay. So what we need to do now is I need you, as the spectator, to freely choose any even number of cards. Any even number whatsoever. Okay? And you'll see why it's even in a second. But any even number of cards. And whatever you choose, I will have to work with that same number as well. But this is a free choice. So what would you like? You want 12? So 12 is your random even number? Okay. So what that means then is each of us will go through our little packets here and deal out 12 cards. Now, you can deal from the top or middle or bottom, wherever you like, but just 12 cards because that's what you asked for. So 1, 2, 3, 4, 5, and then maybe we'll take some from the middle. 6, 7, 8, 9, 10, 11, 12. Okay, so I have 12 cards here, taken from different parts of that packet. And then you do the same. So maybe you do 1, 2, 3, 4, 5, 6, and then 7, 8, and 9, 10, 11. Looks like you ran out, so maybe we'll have to take one from here. 12. Okay, so you've freely chosen 12 cards from somewhere in your portion of the deck. Okay. Now, what I need you to do is I need you to decide on whether we stack from left to right or right to left. We want to sandwich these little cards in the middle so that we don't see them. So you want to go right to left. Okay, so I'll go like that, and then like this. Okay, and then from this point, what we're going to do is we're going to divide the deck evenly. And as you'll see throughout this performance, we're trying to treat each other exactly the same. We're not showing any preferential treatment towards the cards you work with or the cards I work with. Everything we do will be the same. We'll kind of mirror each other. What we need to do is just deal out the cards into a left and right pile. And I'm going to have you randomly choose which half you would like to work with. It really is a free choice. Okay. Would you like the left-hand pile as your pile? Or would you like the right-hand pile? You want the right? Okay, so that will be your little pile, and this is mine, okay? And from this point on, we'll kind of perform a do as I do, or do as you do, I guess, set of procedures. So what we're going to do is we're going to take our individual packet, and so you could pick up yours and do the same thing. We're just going to deal these into smaller and smaller packets, doing left, right. Okay? Now, what we do to decide which one to keep and which one to throw, it's actually fairly simple. We'll keep the odd size piles. So like 1, 2, 3, 4, 5, 6, 7. There's 7 there and only 6 here. So we'll discard the even size packets. We don't need them. And we'll keep the odd size packets. Now there's actually an important reason for that, because otherwise it doesn't make sense what we'll do here in just a moment. Because eventually what we'd like to do is get down to this dealing of left, right, so that there's just one card all by itself. And that's kind of like a lone survivor card. Okay, so you're going to do the exact same actions that I just did. A left, right, or you could start on the right if you wanted, right, left. And then you retain, you keep the odd size pile, which I think is this one. And then this one here has 6. That's even, right? So that's even. So we discard that. Okay. And now we're going to perform that set of actions a second time. So we've done it once. We're going to do it a second time. So here we go. Okay, very good. Now we're going to keep the odd size pile, and that's this one. There's 4 here, so we'll discard that even size pile. And then you'll do the same sort of thing here. Okay, so there's 4. Get rid of those. You don't need those. And keep the 3 there. And now we'll perform these actions one final time, a third time. Okay, so I see left, right, left. Okay, so we're left with an even size pile. Discard that. And then we're left with an odd size pile, which here is just 1. 1's an odd number. And that's nice because now we just have one card left. So left, right, left. Discard the left-hand pile because it has an even number. And so here we are. This is where we've come after we started with a shuffled deck of cards. You randomly cut into 2 parts. Each of us went within each part and chose a card at random for ourselves, right? Then you freely chose any even number of cards to deal out. And I used the same number that you freely chose, right? And then from there, we did a left, right to get 2 piles. You freely chose which pile would be yours and which one I would have to work with. And then from there, we performed identical actions. We did left, right, and discarded the even size piles and retained the odd size piles until we got all the way down to these little lone surviving cards. One for me and one for you. So where has that brought us? So why don't we reveal them together? If you were here, I'd have you flip it over together. Whoa, that's interesting. I don't know. I see something interesting. So do you see anything interesting? Well, I do. I see my card here. Now, you don't see your card as well, do you? Surely not. So the question I have for you is, how in the world did you end up revealing my card? And apparently, if you're not fibbing about this, you claim that I have revealed your card. Well, it's the double reveal principle. That's what did it, okay? Okay, now if you follow the steps exactly, this works every time. Now I have put this video under the Simple Math Card Magic category, okay? And I believe that the kind of the mechanical steps needed for this really do reasonably fit within that category. Now, to look deeply into the mathematics driving it all, that may not be the case. It might push us a bit into the extreme math card magic. So for the video here, I don't think we'll go too deeply into the mathematics, but I do want to review what we did and at least give you a sense as to why it works out the way that it does. Okay? So what is essential for this property here? In fact, maybe I'll even write it on this piece of paper here. Okay? So what you need for this to work is, in fact, why don't we even use the names of the cards that we have here? So here, Ace of Spades. Now that could just represent one of the, either the performer's or the spectator's card. And then we also ended up working with the Queen of Hearts. Aren't those nice cards? Okay. And if you remember, we had those in a little packet of 2 in the center. We had that little pile of 2, and then we had these other cards off to the side. That's what we had. Okay. Now, the double reveal principle will work if the number of cards, it depends on above and below, but let's say over here, this is the top of the deck, top to the bottom. Okay, so if the number of cards below the Queen of Hearts is an even number of cards, and the number of cards above the ace, whoops, I'm making it kind of bigger, I guess, the Ace of Spades is the same, has to be the same even number of cards. If your packet structure satisfies these conditions here, where you have the 2 cards that will be the lone survivors at the end of this process that we'll remind you of, and then above that pair, above those 2, you have some even number of cards, maybe we'll say like 2n. N is just any natural number, and then you have the same number of even cards below the Queen of Hearts. Okay, so our special cards, which will be the lone surviving cards, are sandwiched between the same even number of cards. If that is the case, this will always work. Okay, now, to give you a bit of a sense as to why it works, if you remember, let's see, what did we have here? I think you chose 12, right? As your even number, I think you had 12 cards up here. 12 cards up here, I'll say cards. And then that means 12 cards over here as well. Now, it ends up that the identities of these particular cards are not important at all. We actually don't care what these, in some sense, they're almost like filler cards. They're just taking up room, taking up space. So we need 12 cards above the Ace of Spades and 12 cards below the Queen of Hearts. Okay? Now, if you have a packet like this, if you perform an LR shuffle, okay, so now if you take this whole packet here, and perform an LR shuffle, and you can check this. In fact, let me just give you a hint as to a good way to get a sense as to what's going on. What you can do is essentially build this packet, but have the Ace of Spades and the Queen of Hearts face up, and then these other sets of 12 cards face down. Because if you do that, you can see the movement of those 2 cards. You can kind of see where they get moved. And that starts to unlock the secret of why this principle works. Okay, so if you LR shuffle, this packet, what will happen, this is guaranteed to happen, you'll get 2 piles of 13 cards, right? Because you have 12, plus 12 is 24, plus 2 is 26, half of 26 is 13. So you'll have a little packet of 13 cards, like that. And then you'll have another one, I'll do a little comma, another packet of 13 cards, you know, when you do this left-right dealing. Okay, so maybe I'll just do a little line there. Okay, and now can you guess where these lone surviving cards will be? What position will they be in? What do you think would be their positions within this packet of 13 cards? Well, because of the symmetry of what's going on here, I think, well, for sure, I don't think you'll be surprised to hear that these special cards will be smack in the middle of those, because this is an odd number of cards, and given any odd number of cards, there will always be a card exactly in the middle, right? A middle card. Okay, so what will happen is, you know, depending on, see, left, right, I guess we'd have the ace of spades right there in the middle, and then queen of hearts. And then what you would have is you would have 6 cards. You have 6 cards, you know, like above it. And then you would have 6 cards below it. And then that ace of spades would be right in the middle. And then a similar thing for the queen, right? You'll have 6 cards, sorry, I'm running out of room, above it. And then you'll have 6 cards below it. Okay? Now, the principle that drives it from here is the fact that if you have an odd number of cards and you perform the, quote, LR shuffle, the left-right shuffle, you're going to get a packet of 6 cards and a packet of 7 cards. So you'll get an even-sized packet, 6, and an odd-sized packet, 7. Okay? Now, it ends up that because this is odd, the original middle card here in this packet of 13 cards is guaranteed to be the middle card of the odd-sized packet once you kind of deal these into a left-right, okay? And so what that means then is if you do another LR deal, you'll get a little packet of 7 cards. Okay, 7 cards. And then you'll get a packet of 6 cards. Okay. Well, your ace of spades is going to be smack in the middle of this packet of 7 cards. And of course, 7 is odd. So that ace of spades is now right in the middle of this odd number of cards. Okay? So we discarded the even packets, retained the odd. Well, we're retaining the packet that contains our special card, the ace of spades. And then the same sort of thing happens here for the queen of hearts. It will be the middle card of this, of a packet of 7. Just, you know, it really is identically the same thing going on. Sorry, that almost looks like a 16. Sorry, it's a dividing line. Sorry about that. Dividing line. There you go. Okay, so we discard the 6, and then we retain the odd size of 7, and right in the middle of that is the queen of hearts. And then what happens is that principle is just iterated. It applies again now to the packet of 7 cards. And 7 cards here. So when you go to deal those out, you'll get a packet of 4 cards and 3 cards. And the middle card of that packet of 3 will be your ace of spades. And when you deal out this one into 2 piles, left, right, you'll get a packet of 4 cards and a packet of 3 cards, and the middle card of the little pile of 3 cards will be the Queen of Hearts, okay? And then you're just one more, quote, LR shuffle away from dealing the special cards into their own piles. They'll be all alone, because once you deal the smaller piles of 3 cards, you'll get 2 and 1 for the number of cards. So you discard the pile with 2, and that remaining card will be, one of your lone surviving, one of the cards that you chose at the beginning, that you or the spectator chose. Okay, so this will always work, and it's a powerful little principle that has endless applications. And the way that I presented it here in this video hopefully will make it fairly easy to remember the mechanics. Because once you've chosen your special cards, you've chosen one, the spectator's chosen one, and you just set them in their own little pile, as long as you deal out the same number of even cards on either end here and then stack from right to left or left to right, you will have a packet that satisfies the requirements for the double reveal principle to apply. Okay? And then from that point on, it's, quote, self-working. And self-working just means there's mathematics driving it. The mathematics takes care of it for the rest of the routine. Okay? So anyway, that's kind of an informal view as to what's going on. In the Extreme Math Card Magic playlist, we can go more deeply into the mathematics and the importance of having even numbers of cards here and being of the same size, and the importance of having just 2 cards here that you hope to reveal in the end. Okay, so anyway, I hope you enjoy that, and maybe with this little picture that will help you help remind you kind of how to do it. And I think once you do it 2 or 3 times, I believe this is one that you could remember for the rest of your life, quite honestly. Because if you look at what's happening here in the initial setup, we need an even number of cards above this even number, which is 2. And that same even number here, over here, 12, needs to be below this little pair of cards here. Okay, and then from that point on, instead of the, quote, even numbers being like the important ones to focus on, from then it's the odd numbers, because it's the odd size piles that we retain and we discard the even. And if you do that for each of these separate piles, you're guaranteed to finish with the freely selected card by you or by the spectator. So thank you for watching, and play with that and see if you can come up with your own narratives for applying this powerful principle. And I do also want to point out that once this packet is constructed, I have shown you on this channel ways to supposedly randomize this, but actually leave it in its original order. Okay, so something like the first shall be last and the last shall be first shuffle. That looks like it would be like mixing these up. And if you perform 2 of those, it's, quote, a false shuffle, so it just brings it back to original order. And in fact, what's really nice is if you perform that shuffle, first shall be last, last shall be first, each one of those is equivalent to a packet reversal. Well, if you reverse all of the cards, and as far as like where they are, like the top card becomes the bottom and so forth, if you essentially like read the packet from this direction instead of this, it's symmetric. It won't matter. So a packet reversal of this constructed packet still works just fine. You can reverse the order of all of the cards and go through the entire procedure and everything works great. Okay, so anyway, so you can look at ways of supposedly mixing this up before you even go on to this LR dealing. Okay, and that just further drives home to the spectator of how in the world is this ending possible when I just saw those cards just being mixed and moved all over the place. There's no way any human could possibly have kept track of where things are. And in some ways, they're right. It would be very difficult to track things, but it's the overall structure of the packet that allows this principle to work its magic. So anyway, that's enough. So thank you for watching, and I hope you have fun with that principle.